Quarter 1 Week 2 Science 8 Balanced and unbalanced forces most essential learning competency. Infer that when a body exerts a force on another, an equal amount of force is exerted back on it. In this lesson, you will infer that when a body exerts a force on another, an equal amount of force is exerted back on it. Examine the pictures below showing the pen and the flower vase. What makes the pencil and the vase stay at rest? Picture 1 hanging pencil with a string. Picture 2 flower vase on top of a table. The pen stays in place because of another force acting on it. This force that is supplied by the string is being referred to as tension force, T. Tension force is a force which is transmitted through a string, rope, or wire when it is pulled tight by forces acting at each end. The vase, on the other hand, stays at rest because of the force pushing it in upward direction being exerted by the table, which is being referred to as normal force, Fn. Both the tension force and normal force counteract the pull of gravity, Fg, that acts on objects, which makes them to stay at rest. In both cases, you can now infer that the objects remain at rest because the forces acting on the pen and on the vase are equal in magnitude in an opposite direction and they lie along the same line of action. These forces are said to be balanced. What is balanced force? Balanced forces are forces that are equal in magnitude and are opposite in direction, so there will be no motion in an object. There are some examples where you can see balanced forces in our everyday activity. This includes standing on the ground, floating in water, hanging objects, and a play called tug of war. In these activities, the effect of one force is cancelled out. Combining forces for you to determine the net force or unbalanced force, you have to recognize those forces that act along the same line of action. The algebraic sign positive, plus, and negative are used to indicate the direction of forces. Below is a force diagram. You have there the line of action of pen and vase. The forces acting on the pen was the tension of the string, and the weight of the pen, which is acceleration due to gravity multiplied by the mass of the pen. The forces acting on the vase was its weight and the normal force upward of the table. Remember your lesson in mathematics, the use of positive and negative signs in integers. Negative signs are used for forces acting in opposite direction. Examine the force diagram below. The vase line on top of the table has the force of gravity, Fg, assigned with the negative sign. The direction is downward. While the normal force, Fn, is given a positive sign, the direction is upward. If both Fn and Fg are given a magnitude values of 5 units, then the two forces will cancel each other. Thus, the net how will you compute for the value of forces acting on the line of action? You may follow the Gressa method. What is Gressa method? It is a systematic way of solving a given problem with its acronym that means G, given. These are the values stated in the problem. R, required. This is the value to be computed. E, equation, is the mathematical expression to solve what is required in the problem. S, solution, is substituting the given values in the equation. And A, answer, which is expressed in proper unit. S. The vase on top of the table illustrated in learning task number 3 and on the force diagram above tell you that the vase stays at rest because it has a normal force of 5 units and gravitational force of 5 units also. Let us use the Gressa method to determine how a net force of 0 is computed given Fn, normal force, is equal to 5 units, Fg, gravitational force, is equal to 5 units required, net force. Equation, net force is equal to Fn plus Fg. Solution, net force is equal to 5 units plus negative 5 units, is equal to 0. Answer is equal to 0. If the sum of all the forces equates or equals to 0, the forces are considered balanced. If the algebraic sum is not equal to 0, the forces are not balanced. The non-zero sum is the net or unbalanced force. This unbalanced or net force would cause a change in a body's state of motion. Unbalanced force is in a situation where a pen is attached to a string and the string is cut from the hanging pen. The pen fell because there is no force acting on it to counteract the pull of gravity. If you push the vase on one side across, the vase will move, but it will not continue moving if you don't continuously push it. The vase moves because of the applied force. So the forces acting on it are no longer balanced. If an object initially at rest is under an unbalanced force, it moves in the direction of the unbalanced force. How about if the object is in motion? How will the unbalanced force affect its motion? Learning task number 1. Identify the situation if it shows balanced or unbalanced force. Number 1 picture is 2 girls pulling a rope, is having a balanced force. Number 2 picture is a girl standing still, is having a balanced force. Number 3 picture is a tug of war, is having an unbalanced force. Number 4 is a picture of a skydiving, is having an unbalanced force. Examine the illustration of a rolling ball below. There's another force that acts on the ball along the horizontal line or along the force that makes the ball in motion. This is called friction force, FF. Friction is a force that acts between surfaces that are in contact with one another. Friction in general acts opposite the direction of motion. In the case of the rolling ball, the frictional force acts between the surface of the ball and the table and slows down the motion of the ball. As the ball rolls to the right as shown in the illustration, friction acts to the left to delay its motion. Pushing the ball will keep the ball rolling, but since there is no force done to move it continually, there is no force to balance a force of friction, so the ball slowed down and eventually stopped. Again, because of the unbalanced force, the object changes its state of motion, so you can say that it accelerates. Take note of this: acceleration is not just an increase in velocity, but also a decrease in velocity when it slows down to stop. Learning task number 2. Study the diagram showing the forces acting on the rolling ball above. Answer the guide questions. Guide questions. Number 1. What do you call the force acting on the ball along the horizontal line or along the force that makes the ball in motion? What is the answer? The correct answer is unbalanced force 2. What makes the ball stop on rolling after some time? What is the answer? The correct answer is frictional force 3. What makes the ball keep on rolling? What is the answer? The correct answer is unbalanced force. Learning task number 3. Examine the pictures below. Determine if the activity shows balance or unbalanced force in each situation. Number 1 is a man pushes a car, is having an unbalanced force. Number 2 is a boy hits the ball using a bat, is having unbalanced force. Number 3 is air rushes down, is also having unbalanced force. Number 4 is a hammer touches the nail, is also having unbalanced force. Learning task number 4. Solve the problem about balancing unbalanced forces using Gresham method. Number 1. A boy and a girl are pulling a heavy crate at the same time in the same direction, exerting 7 units of force each. What is the net force on the object? Is the object balanced or unbalanced? The answer is 14/10, is having unbalanced. Number 2. What will be the net force of the object if a girl and a boy pull the heavy crate at the same time in opposite directions with 10 units and 20 units of force, respectively? Will the object move? To what direction will it move? Answer. The net force is 10 units to the right and the object will move to the right, having unbalanced force. Number 3. Suppose another girl pulls the heavy crate with 10 units of force in the same direction as the girl. What will be the net force that will act on the object? Will the object move? Answer. The net force is 0 and the object will not move, and having balanced force. Learning task number 5. Choose the letter of the correct answer. Number 1. What forces act on the vase on top of the table? 1. Force exerted by the table. 2. Force of gravity. 3. Tension force. 4. Spring force. A. 1 and 2 C. 1, 2 and 3 B. 2, 3 and 4 D. 1, 2, 3 and 4. What is the answer? The answer is letter A, 1 and 2 choices. Number 2. All vehicles have inertia. Which has the greatest inertia among the given vehicles below? A. Car. B. Truck. C. Bicycle. D. Motorcycle. What is the correct answer? The correct answer is letter B. Truck. Number 3. When the forces that act on an object are opposite in direction and equal in magnitude, the forces are said to be A. Friction. B. Balance. C. Gravitational. D. Unbalanced. What is the correct answer? The correct answer is letter B. Balanced. Number 4. Which statement causes the rolling ball to stop when there is no force applied on it to push it continuously? A. Forces acting on the rolling ball are already used up. B. Friction causes the rolling ball to stop. C. Unbalanced force causes the rolling ball to change its motion. D. Gravitational force causes the rolling ball to change its motion. What is the correct answer? The correct answer is letter B. Friction causes the rolling. 5. What are the forces present on a lantern that is being hung on a tree? A. Normal force and tension force. B. Frictional force and normal force. C. Gravitational force and normal force. D. Gravitational force and tension force. What is the correct answer? The correct answer is letter D. Gravitational force and tension force. 6. When the net force of an object is equal to 0, then the forces are said to be A. Balanced force. B. Unbalanced force. C. Gravitational. D. Air resistance force. What is the correct answer? The correct answer is letter A. Balanced force. The content of this video is mostly from the Calibars in Science 8 Learning Module Quarter 1 Week 2, and the GIFs and some pictures are from online sources.